So we've looked at one method of using matrices to solve systems of equations. This new one we're going to look at is called inverses. So let's think about something for a second. So inverse operations. The inverse of adding is subtracting. The inverse of multiplying is dividing. So we have inverses that can undo each other. So in other words, if I multiply two things times each other and get the identity matrix back, then they are definitely inverses of each other. So if I took these two matrices and multiplied them together, we're going to see if they're inverses. And just some notation, remember back in algebra, if we had the inverse of a function, so the inverse of f of x was denoted with a little -1 at the top. We do the same thing with matrices. So an inverse matrix is denoted with a little -1 at the top as well. So we're going to test to see if A and B are indeed inverses of each other. So we're going to multiply them together and see if we get an identity matrix back. So the one with all the ones and zeros. So I'm going to go to a matrix, 1, 2, 1, whoops, 1. And then I'm multiplying that by matrix B. So we're multiplying A times B. I'm going to see what we get. So -1, 2, 1, -1. And it indeed gave me 1, 0, 0, 1. So that is an identity matrix I. So this is a yes. Now, finding the inverse of a matrix, there is a way to do it by hand, but of course, we can also do it in the calculator. So what we can do is we can take this matrix and go to the -1 of it. So A to the -1 is going to be my matrix, my inverse matrix. So 2, 5, 4, 1, 4, 3, 1, -3, -2. So as long as it's a square matrix, the calculator can find that. So I'm going to take this matrix to so I'm going to use that exponent, -1. This is finding the inverse matrix. And so it's giving me a brand new matrix that is indeed its inverse. It would undo that matrix. Now, there is also a way to do it by hand, but we are not going to worry about that. So remember when we had the lesson where we had the secret code, which, by the way, this should be a 25. It's a typo. And we had used the encoding matrix A to convert pairs of numbers to be a matrix and to convert them. What we're going to do is we're going to take the inverse matrix, times this previous message. So the way we ended up grouping them together, and I'm going to kind of do this all at once this time. I'm going to make a new matrix of 96, 118, 65, 84, 131, 168, 55, 72. So I'm going to find the inverse of the encoding matrix. sorry about the glare. So 3, 5, 4, 6, and I'm going to the -1. And it gives me my inverse matrices. Whichever way I want to write it is fine. I'll go with the decimals, 2.5 to -1.5. What I'm going to do is take this matrix times this matrix with our coded message. So I'm going to take this previous answer times 96, 118, 65, 84, 131, 168, 55, 72. And it gives me 7, 15, 15, 4, 27, 10, 15, 2. Let's see if we can recall what it gives me. So we had put these in like that. So this is 7, 15, 15, 4, 27, 10, 15, 2. If I go back to the table with the code, 7 was G, 15 was O, 4 was D, 27 was a blank, 10 was J, O was 15, and 2 is B, and good job. So we not only encoded a message, we decoded it. Now, we saw augmented matrices as one way to set up a matrix equation or solve matrices. Another way is to turn this matrix into a matrix equation. So this has all of my coefficients, 2, 5, 4, 1, 4, 3, 1, -3, -2. This has all my variables, and this has the equal side, those constants. So let's think about something. This is A times, let's call this matrix X equals a matrix B. Well, how would I solve that equation? Well, we would normally divide by A. Well, I can't divide matrices. But what I can do is multiply by the inverse. So if I multiply by the inverse of A, got to multiply this side by the inverse of A. These two end up becoming the identity matrix, so they basically cancel each other out. To solve this matrix equation, I would take the inverse of A times B. So we've got this already kind of set up as matrix A and matrix B. So I'm going to be taking that 2, 5, 4, 1, 4, 3, 1, -3, -2. But we're going to do the inverse of that times B. What it's going to give me is the matrix X, Y, Z. So it's going to give me my solution in order, X, Y, and Z. So I'm going to do matrix 2, 5, 4, 1, whoops, 1, 4, 3, 1, -3, -2. But I'm doing the inverse of that. So exponent, -1, then matrix 4, 1, 5. It gives me the matrix 3, -2, 2. It's giving my X, Y, and Z. Now, there are a lot of reasons why this one tends to end up being kind of a preferred way. And that's because it can be applied in a lot more situations than the augmented matrix. Okay, so we have an example with medication. Medication A is given every 4 hours. Medication B is given twice a day. Find the ratio of the dosage of A to dosage of B is always 5 to 8. So medication A is given every 4 hours and medication B is given twice a day. So we know every 4 hours, that would be 6 times a day. So 6 times per day and twice a day. The ratio of the dosage of A to B is always 5 to 8. So A to B is always 5 to 8. A to B is 5 to 8. Okay, so in the first example, patient Bob has a total intake of the 2 medications of 50.6 milligrams per day. So he's taking 6 pills of A, so 6A, and he's taking 2 pills of medication B for a total of 50.6 milligrams. Now they have to be in this ratio. So that's kind of an interesting part on this, is that we have a ratio. And I would rather it set up like this. So the first thing I'm going to do is cross multiply. So 8 times A would equal 5 times B. So 8 times A, let me write it up here. 8 times A equals 5 times B. But I want it to look more like that. So I'm going to subtract that 5B and get this equation. So 8A minus 5B equals 0. So my coefficient matrix would be the matrix 6, 8, 2, negative 5. And we're going to take the inverse of that times the answer matrix. So matrix 6, 2, 8, negative 5. And we're doing the inverse of that matrix. And then matrix 50.6 over 0. Now what it's going to give me is it's going to give me A and B. So 5.5 of medication A. So A is 0.5 milligrams. And B, Bob should take 8.8 milligrams of medication B. For patient Jane, the total intake of the 2 medications is 92. Find the dosage of each administration. So all we're changing is 92 for the 50.6. So 6A plus 2B equals 92 this time. They're still in the same ratio. So I'm only going to change that 50.6 to be a 92. So I'm just going to go up and copy and then come in here and change that 50.6 to be a 92. So A for Jane is going to be 10 milligrams and B is going to be 60 milligrams. Let's do one more. Freight logistics. On-time freight carries 3 classes of cargo. Class 1, Class 2, and Class 3. And sets its delivery rates according to the class. The following table gives the particulars for the products. find the number of units each cargo class that should be hauled. So this is going to be my X, Y, and Z. We're trying to find how many units of each cargo we will have. So it's going to be 25 cubic feet of X plus 20 cubic feet of Y plus 50 cubic feet of Z equals 15,000 as my limit. So 25X plus 20Y plus 50Z equals 15,000. 25X plus 50Y plus 100Z equals 27,500. 2,500X plus 500Y plus 5,000Z equals 922,500. Sorry, I can't write. Now remember, we're just doing the coefficient matrix inverse times the answer matrix. So 25, 20, 50, 25, 50, 100. So we're just typing in all those coefficients. So basically all those numbers from the table, other than the limits to the -1, and then matrix 15,000, 27,500, and 922,500. And it gives me 254 of class 1, 385 of class 2, and 19 of class 3. What would change if an additional 300 cubic feet of volume becomes available? So what we're changing is the amount of volume that comes available. So this is changing to 15,300. So this is going to be 15,300. Everything else is staying the same. So why not just copy it and change that to be 15,300? So if that happens, we want 286 of class 1, 405 of class 2, and 1 of class 3.